All right, this is lesson 432, part 2. We're going to continue to learn how to simplify radical expressions. And you should have found out by now that the square root of x minus the square root of y is not equal to the square root of x minus y unless x and y are the same. Are equal. So, but in most cases, you should have found that it isn't true. And also you should have figured out that, and I'm going to write this a little bit differently because I like this way better, that the square root of x divided by the square root of y is equal to, you can go ahead and divide x and y first and then take the square root. And that is true for all positive values for x and y. And in fact, x could even be 0 and it would work. But, all right, so we're going to use those ideas to help us simplify radical expressions. Here's an example. Now, for a radical expression to be simplified, and I'll talk about this more again, but what we need is when we look at the radicand of a radical expression like this one, we want to make sure that that radicand has no perfect square factors. So we have to do a little bit of review on what perfect squares are. Now the deal is, if it's a perfect square, then we can just write it as the whole number that it is. We don't have to write it as a square root. So we're looking for these numbers. The first 10 perfect squares are, and we're never going to look for 1 because the square root of 1 is just 1 and it becomes redundant. But so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. The next one is 49, then 64, then 81, then 100. I'm going to continue here because we might find these useful. 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225, 16 times 16 is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So those are actually the first 20 perfect squares. Now if we can identify those, we can use those to help us simplify radical expressions. All right, and here's the way you're going to do that. First, list all the factors of 28 except one. So I'm going to make a little exception here, except 1 and itself. We don't want those. If the number itself is the perfect square factor, then we know how to deal with that. We just take the square root of it and write it as the whole number. But so we're going to list 2 goes into 28, 4 goes into 28, 7 goes into 28, and 2 times 14 is 28. So 14 goes in there. So those are all the factors. Now we want to circle the perfect square factors. And so we're going to go back, think about the list that we just wrote on the last page. Which of the factors of 28 are in this list of perfect squares? And it may take you a bit, but you should notice that 4 is the perfect square factor. Now to simplify this, we're going to write the square root of 28 as a product using the perfect square factor and a couple of those number properties that we just discovered. We can write 28. I can write it a lot of ways, and don't write this down. I'm just going to show you. I could write it as the square root of 2 times the square root of 14. I could write it as the square root of 4 times the square root of 7. Either of those, but the one that I want to write it as is the square root of 4 times the square root of 7. You should write that down because the square root of 4 is a perfect square factor, and we can just simply write the square root of 4 as the whole number 2. So we get 2 times the square root of 7. And in algebra, we don't use that times symbol when we're writing expressions like this. We just write 2 times the square root of 7 like that. So 2 times the square root of 7, and if you don't believe me, it's true, that is the same as the square root of 28, and it is considered simplified because the 7 has no perfect square factors. The only factors of 7 are 1 and 7, and neither of those are perfect squares. So this is considered simplified. And you might want to check to make sure your simplified answer is the same as your original answer, so you can get the decimal approximation of that. The square root of 28 is 5.29. This 2 times the square root of 7 is also equal to 5.29. And 2 times the square root of 7 is considered to be the simplified form of that number. All right, so we're going to try and simplify negative square root of 50. So we're going to list the factors of 50 other than 1 and 50. So we know 2 goes into 50, 5 goes into 50, 10 goes into 50, and 25 goes into 50. And then we want to look at this list and see if any of those are perfect squares. What I mean by that is there some number multiplied by itself that equals 2? That's a whole number? No. 5? No. 10? No. 25? Yes. 25 is 5 times 5. So the square root of 25 is just 5. All right, now we're going to use that information. Let's just put the negative sign out here. And we're going to rewrite the square root of 50 using 25 and whatever number multiplied by 25 equals 50, which is the square root of 2. And the square root of 25 is, that's 5, right? 5 times 5 is 25, so we're going to write negative 5 times the square root of 2. And I'm just going to get rid of that dot I'm using to show multiplication. And so negative square root of 50 simplified is negative 5 times the square root of 2. All right, this next one's a little more complicated because it has some variables in it, but just remember this. Here's just some variable. Let's say I have w to the 4th, and I want to read the square root of that. Well, just think, what number multiplied by itself equals w to the 4th? And of course, that's this, w squared. So the square root of w to the 4th is w squared, as long as w is a positive number. And if I have the square root of w, let's say, to the 10th, that is w to the 5th. Because the way I would check that is I would just do this times this, and we remember when we're multiplying with the same base, we add the exponent, so that's w to the 10th. So if it has an even power, it's a perfect square. Then we can break it down, simplify it. So when we list the factors of 24, a to the 4th, b to the 2nd, I'll list them all, and then we'll look at those. We're not going to list 1 or 24, but we know 2 goes in there, 3 goes in there, 4, 6, 8, and 12. And we also have factors of a to the 4th. Factors of a to the 4th are a to the 1st, a to the 2nd, a to the 3rd, and a to the 4th. And the factors of b to the 2nd are b and b to the 2nd. Now, if I look at these and say which of those are perfect squares, here's one. And any even power is a perfect square. So that's a perfect square, that's a perfect square, and that's a perfect square. And to make your simplifying process go a little bit easier, you always want to use the biggest perfect square factors that you can when you rewrite your radical expression. So I'm going to get rid of this a to the 2nd. I'm not going to use that one, but I'm going to use those 4 and a to the 4th and b to the 2nd in my product. So the square root of 24, a to the 4th, b to the 2nd, I'm going to rewrite using a bunch of little square roots. I'm going to use the square root of 4, because that's a perfect square. And we have to multiply that times the square root of 6 to equal 24, so there's that part. And then a to the fourth, I'm just going to write it as the square root of a to the fourth, because it is a perfect square. And b to the second, we can just write that. That's a perfect square also. Any even power of a variable is a perfect square. And then I'm going to simplify any of these I can. The square root of 4 is 2. Square root of 6, we can't simplify that. No, 3 is not equal to the square root of 6. Square root of 9 is equal to 3. Square root of a to the fourth is a to the second. And the square root of b to the second is just b. b times b is b to the second. And then I'm just going to rearrange those so I have my radical, any radical expression I have left in the end, and the other parts of the numbers all put together. And I usually put my variables in alphabetical order. So 2a squared b times the square root of 6 is the simplified version of the square root of 24, a to the fourth, b to the second. All right, I'm going to try and do a couple more of these with you. I'm going to do the square root of 50x to the third. And so we're thinking of what numbers are perfect square factors that 50 has. And some of you probably figured out right away it's 25 is a good perfect square factor. So 25 times 2 is 50. Now out of x to the third, we can actually factor the x squared part of that, because x squared times x is equal to x to the third. So that's how I'm going to simplify it. And the square root of 25 is 5. X, the square root of 2, we can't simplify that at all. Square root of x squared is x. And the square root of x is not, there's no perfect square factor of the square root of x. And I'm just going to put these two together that are simplified from that, and put the other two that aren't simplified back underneath the radical expression. And that's how you would go about simplifying it. All right, a couple more. All right, let's do this one here. 5y times the square root of 3 is a simplified form of, well, let's think about that. To get 5, we must have had a factor of the square root of 25. So I'm going to write that down. To get y, we must have had a square root factor of y squared. And then the square root of 3 was what was left over. And then we can just combine all those. 25 times 3 is 75. And y second underneath the radical. That's what we must have started with to get that. All right, I think I'm going to stop here and we'll finish the rest of the class. I guess I got time for one more. All right, what are the square root factors of 48? Which would you use to simplify the square root of 48y? Let's write them down. 2 is a factor of 48. 3 is a factor of 48. 4 is a factor. 6 is a factor. 8 is a factor. 16 is a factor. And 24 is a factor. Now, the perfect squares there are 4 and 16. And we would use 16 as a factor because then it would make the process go a lot faster. We could just write the square root of 48 as the square root of 16 times the square root of 3, and the square root of 16 is 4 times the square root of 3. So you always want to use the biggest perfect square factor that you can find in the problem. All right, we're going to have one more lesson here on simplifying radical expressions.